Why am I the only one here?
Yo! What's up, dude?
What?
My name is Mr. Doge, and I will be your instructor in today's class about Iridium.
Huh? What's iridium?
Iridium is a silvery white metal with a tinge of yellow that was discovered in 1803 by a fine gentleman with the name of Smithson Tennant.
Whoa. Slow down. Where's everybody else? Where's Mr. Regular T-Shar?
He called in sick today. So did the rest of the students. Apparently they caught dumb sub-itis. My field doesn't extend to medical science, so I don't know what that means. But no matter.
Dumb sub-itis? Oh no. This is gonna be so boring.
Let's get started. Iridium is one of the coolest elements on the periodic table. As you can see, its symbol, IR, is located in the 6th period and 9th group, which means that it is in the transition metals family, has medium reactivity, and has 6 electron shells. Also, since it is in the bottom 2 periods, it has a high density. Its atomic number is 77, which means that its nucleus has 77 protons. As is made obvious by its family name, iridium is a metal and solid at room temperature. Together with 77 protons, iridium's nucleus contains 116 neutrons as well, making its mass number 193. That is to say, if we are speaking about iridium's most abundant isotope, Iridium-193.
Wait a minute. What's an isotope? And that table says that iridium's atomic mass is 192.22.
But an element's atomic mass, or atomic weight, and its mass number are two different things. Take a look at this model. As you can see, the atom resembles a ball of tightly packed nucleons, or protons and neutrons, with rings of electrons around it. There happen to be 77 protons and 116 neutrons in this ball, even if you can't see all of them. The mass number is the protons and neutrons added together. Different versions of iridium have different numbers of neutrons, resulting in different mass numbers, like 191 and 193. These versions are called isotopes.
I see, but then what's the atomic mass?
The atomic mass is the average mass of the natural isotopes, taking their abundance into account. This happens to be 192.22. There aren't just 2 isotopes of iridium either. Iridium's 191 and 193 are the naturally occurring ones. There are also 34 synthetic radioisotopes.
Wow, that's a lot. What about the electron rings?
Those are called shells. Iridium has 6 because it lies in period 6 of the periodic table, as we covered earlier. Each shell has a certain number of electrons, adding up to 77 total, the same as the atomic number. In order, iridium's shells have 2, 8, 18, 32, 15, and coolest of all, 2 valence electrons.
Valence electrons?
Valence electrons are the electrons in the outer shell. These are the electrons that move about during ionic bonding.
Ionic bonding?
Ionic bonding is the kind of chemical bonding we will cover today. It involves ionizing 2 elements, or altering their numbers of valence electrons and bonding them into a molecule.
Really? This is starting to sound interesting.
I'm glad you say that, because this information will become very useful later when you devote your life to studying atomic science.
Wait a second here.
But you don't have to worry about that right now. I have prepared an animation which demonstrates iridium forming an ionic bond with chlorine to make a salt. First it shows all the elements' information. Now, as we get to the interesting part, you can see that iridium has 2 valence electrons and each chlorine atom has 7 valence electrons. To make a bond, each element must either fill its valence shell to 8 or empty it to 0. The single iridium's charge, which is neutral currently, must be balanced with the charge of the combination of chlorine atoms, which is also neutral. Each chlorine atom just has to gain 1 electron to fill its shell and lower their combined charge to -2. The iridium atom will donate both of its valence electrons to achieve this, to empty its shell, and to raise its charge to +2. Then, the charges will be balanced and iridium 2 chloride, one of iridium's most common salts, will form.
Understand? What?
That's the spirit. Now, to reinforce your already strong grasp of the concept, I'll play the animation.
Makes sense. I guess that was cool, but why exactly am I learning all these things about iridium?
Why? Because iridium is such a wonderful and useful element. Did you know that iridium is the most corrosion-resistant metal? In 1803, it was discovered by Smithson Tennant after it was left behind when he dissolved platinum in aqua regia, an extremely powerful acid. It's also the second densest element, outweighed only by its stable partner, osmium. Additionally, iridium is extremely hard and difficult to work because of its blazing hot melting point of 4,436 degrees Fahrenheit. Not only that, but iridium was named after the Greek rainbow goddess Iris for its colorful salts. Iridium is used mostly for things which require extremely durable or heat-resistant materials. For example, pen tips, satellites, rings, and, my favorite, spark plugs. Perhaps its most amazing use of all is that it's one of the key materials in brachytherapy, which can be used to cure cancer in some cases.
Wow, those are some awesome qualities. When I get home, I'm gonna get myself loads of iridium.
Well, it's not gonna be that easy. Iridium is the 3rd least abundant element in the Earth's crust, so it's $520 per 31 grams.
But why is it so rare?
Scientists theorize that because of its unusually high density, iridium sank deep into the Earth's crust back when it was molten. In fact, this quality led to the theory that an asteroid wiped out the dinosaurs.
Really? How did it do that?
At the layer of the Earth's crust associated with the dinosaurs, strangely high amounts of iridium were found. Since it is known that iridium is a lot more abundant in meteorites, this led to the theory that an asteroid containing high amounts of iridium killed the dinosaurs.
I never knew that. Oh, the bell.
Your only homework is to teach this lesson to each and every one of your classmates.
Okay, I'll do that. Thank you for teaching me the lesson, Mr. Doge. At first I didn't think it was going to be interesting at all, but actually it was quite cool. Bye, Mr. Doge.